target today is I can identify reflections on a coordinate plane. So the question is, what is a reflection? So we talked about translation. When we slide without turning or flipping, we keep it congruent. But in today's work, we are actually going to flip for a reflection. So it is a flip of a figure over the line of reflection. So you can see an example here with the bike. The handlebars are right here. Here's the line of reflection, and then the handlebars are right there. So when we flip it over, that you can see it gets flipped. When we flip it over, it gets flipped. That's funny that I said it that way. And it does need to stay congruent, okay? And it needs to be equidistant to the line, okay? So if you were to fold it on that line, it would land right on top. So it has to be the same distance away from the line. So some notes is that it has to stay congruent, same size, same shape, and it has to be the same distance away from that line when folded. Other language that we just talked about the last time is the new figure that we create is called an image. So the new figure so after we flip, the new figure is called the image. So let's first talk about whether something is a reflection or not. To tell whether the blue figure is a reflection of the red figure, we're supposed to say yes or no. Is it? So here's the line. Is it true that the blue figure, when flipped over the line, is a reflection? Which means, did we flip it to make it a reflection? If we look at this blue to red, no, we did not flip it, so it's not a reflection. In fact, it looks more like a translation, like a slide. So I can stop right there. It does appear to be congruent. It does appear to be the same distance from the line, but it never got flipped, so it is not a reflection. Example 2, here's the line of reflection. You can see that the blue figure did get flipped over that line. Is it congruent? Same size, same shape? Yes, so it is a flip. It's congruent. And if we look at the distance from the line to the corner, it is the same distance from line to corner, so same distance away. So this would definitely be a reflection by definition. So same plan on these three. So why don't you take a look at these three and decide, is it a reflection from the blue figure to the red figure? Pause the video, say yes or no, is it a reflection? All right, y'all, we're going to have you unpause that video and see how you did. So the first one, from blue to red, did we flip it over? Well, here's the point of what's called the pentagon. If we flip it over the line, the point of the pentagon should land right there. Because when we fold on that line, they should land on top of each other. So it definitely is not a reflection. It did not get flipped. It looks more like a translation or a slide. So no, not a reflection. The middle example, here's my line of reflection. Is it true that I flipped the triangle over the line? Is it true that it's a flip? No, never flipped it. Again, looks more like a slide. The next example, here's my line of reflection. Is it true that the blue trapezoid got flipped over the green line and lands? When we flip it, does it land right on top? Because that's super important to be a reflection. It does appear that it is. So it looks like a flip, yes. Does it look congruent? Same size, same shape? Yes. Does it look like it's going to land right on top? Yes. So we would say that that definitely looks like a reflection. All right. So the you try question. It says, which one of these doesn't belong? Which transformation does not belong with the other three? So you have these 4 hat problems. Which one does not appear to belong? So let's take a peek. Why don't you go ahead and try to figure that out and unpause. So hopefully you gave it a shot. Here's my line of reflection. Does this look like a reflection? Yes. Here's my line of reflection. Does this look like a reflection? Yes. Here's my line of reflection. Does this look like a reflection? No. This looks like a translation. We never flipped the hat. I'm going to double check on the last one. Here's my line of reflection. Does that look like a reflection? Yes. So which one doesn't belong? This one right here. It appears to be a translation. All right. Tell whether the blue figure is a reflection of the red figure. So we're going to go through A through F. I'd like you to pause the video and you simply just need to say yes or no. The beauty of this lesson is you don't have to show a lot of work. So that's super exciting for many of you. So So here's my line of reflection. Does it appear that we flipped over the line of reflection? Yes, it looks like it's flipped. Does it appear to be congruent? Same size, same shape? Yes. Does it appear that it will, if we were to fold it, that it would land right on top? Yes. So we're saying yes, that looks like a reflection. If you've not tried the rest, please do that right now. All right, so for part B, does this appear to be a reflection? Does it appear that it'll land right on top of each other? No. So we're just going to move on. See, here's my line of reflection. Definitely two triangles. They actually do appear to possibly be congruent, but my concern here is when I flip it, will it land exactly on top? These look like they maybe would align. However, the huge dilemma is this point right here, when flipped, is going to land right there. So does this look like a good reflection? I'm going to say no. It doesn't appear. And likewise here, this red corner, when I flip it, does it land exactly on the blue corner? I'm going to say not a reflection. D, here's my line of reflection. If I take the blue and flip it over the line, does it appear that the blue triangle land right on top of the red triangle? Does it appear that it's going to land on top? No, because it actually looks like a slide rather than a reflection. So it never got flipped, so I'm going to say no. E, does this appear to be a reflection? Well, let's see. They both look congruent. They look the same distance from the line. They look like they could land on top of each other. And is it true that those points would land on each other? I think so. I think so. What about this one? Does it appear it will land on that one? I think so. What about this one? Does it appear it lands on that one? Yup. And so on. So I'm going to say yes, that appears to be a reflection. It looks like it's going to land on each other. It is congruent. I believe it's a reflection. Here's my line of symmetry. I'm going to undo that just to verify. Are they the same distance away from the line? Yes, they are. Okay. So does this appear to be a reflection? Are they congruent? Yes. Does it appear the blue arrow, when flipped, would land right on top of the red arrow? They're the same distance from the line. We're going to say yes. So that is the first examples of, do we have actual reflections here? Okay. So now let's talk about when we graph something. So what happens when we reflect on the coordinate plane? It says the coordinates of a point and its image are given. So here's the point, we'll say A, and here's the image, we'll say A prime. Is the reflection in the x-axis or the y-axis? So let's take a peek at this xy coordinate. That would be right 2, down 2. So right 2, down 2 is the coordinate A. And what we're going to do is we're going to reflect that in some direction. So let's go graph this coordinate here. Positive 2, positive 2. So right 2, up 2 is B. So there is a reflection that's happening. We have to decide what was the reflection. It looks like we reflected over this line right here, which we call the what? The x-axis. So this one appears to be a reflection over the x-axis. And you know what, guys? I misspoke here. This should have been A prime, because that A point got reflected. It got moved, essentially. So it's the image. We call this the image. So when we write that little apostrophe here, that means it's the image. It means it's the new point. Okay. Next problem. Let's go ahead and plot these points. I'm going to change color if I can and get into a different mode of color so that we can kind of, it kind of pops out at us. Okay. So -4, 1, 2, 3, 4, +1. So we'll call this B. We'll call this B prime, the image. So +4, +1. So +1, 2, 3, 4, +1. And you can see that this is reflected, that's the B prime. That's the image. Over the what axis? We call this the YMCA axis, the y-axis. So that definitely was a reflection over the y-axis. Okay, final of the day. In this last problem of the day, we're going to merge two skills together. We're going to merge the translation together and the reflection together. So here's our triangle. All right. And we are going to translate it 1 unit to the right and 5 units down. So the translation would look like this. X, when we move to the right, is x plus 1. When we move down, is minus. So x plus 1 is right 1, down 5. So we're going to take that and move each coordinate. Right 1. So I'm going to take t and move it right 1, down 1, 2, 3, 4, 5. And we're going to call this t prime. And I'm going to do the same thing with s. I'm going to go right 1, down 1, 2, 3, 4, 5. And I'm going to call that s prime. And we're going to take r. We're going to go right 1, down 1, 2, 3, 4, 5. We're going to call that r prime. So this is my new triangle. R prime, S prime, T prime, the new image. It has been shifted right 1, down 5. So now that we've done that, so that was part A, which is our lesson from two lessons ago, right? So now the most recent lesson was now we reflect. And it says that we're going to reflect the image, this new one, this image. We're going to reflect it over the y-axis. So let's identify the y-axis. Here's our y-axis, and we're going to reflect it over that. That is a really big line there, so I want to redraw that. Okay. So when we reflect it, it has to be equidistant, the same distance from the line. So the t prime point is 1 unit to the left of the line. So when we flip it, this is going to become t, what we call double prime. So this was my t prime over here. T double prime, and it's this giant point right here. The s appears to be 1, 2, 3 units away from the line, the s prime. So I'm going to, when I flip it, it becomes 1, 2, 3 units away, and that's s double prime. And the r prime appears to be 1, 2, 3 units away. So when I flip it, it's 1, 2, 3 units away, which is my r double prime. So my reflection then appeared over the y-axis looks to be this, r double prime, r, or t double prime, r double prime, s double prime. So things I want you to pay attention to is when we did that reflection, when you flip over that, the height of the triangle does not change. But what did change is that the x was over here was -1, -1, -4. When we flipped it, it became +1, -4. So you'll notice what does change when we reflect over the x-axis or over the y-axis is the x-coordinate did change. That's just kind of a bonus information for the lesson, is just notice what happened to the x-coordinate. When we flipped, the x changed, right? The left-right kind of location changed, but the up-down did not. That's if you flip over the y-axis. All right, so learning target today was I can determine if something was a reflection. You just want to make sure that it's congruent, it's the same distance away from the line, and that if you were to fold it, it would actually land on the line. Have a glorious night.